One more thing that we are missing is the initial explosion that will break this part of the building, the corner column, and start a chain reaction where the building collapses. So what I usually try to do when simulating is recreate what would happen in real life. In this case, I want to shoot the cannonball through the wall with a very high velocity and high force. So let's see how we can do this. Let's jump up to the object context and let's take a look at the collision geometry, or actually the cannonball. And remember, this is just a sphere. And for now, I will increase the size just to make more obvious what we're doing. Also, let me ghost the building. So we're going to shoot this cannonball towards the right and a little bit towards C. So it impacts here on the column and creates this explosion. So again, I'm going to copy this output node with Control C, dive back into my DOP network. And there's several ways that we can do this. For example, we could create another RBD packed object and merge it. But in this case, I'm going to use an RBD object. In this case, both approaches would work. So let's add a merge node. Connect this new RBD object to the merge. And let's look for the sub path and paste the node that we just copied. So this is pointing to the cannonball. So right now, if we just press play, the sphere would fall down and hit the floor. So what we need to do is, under our RBD object, look for the initial state parameters. And here you can add a velocity or an initial velocity to mimic the cannonball being shot. So let's try with 200 meters per second in X direction and press play. So now the cannonball will shoot very fast towards the right, break the wall, and since the cannonball is quite large, it will also break these connections that are on the slab and break a huge part of the slab. So after doing a few iterations, I decided to altogether break the constraints that are here where the ball will impact, just to avoid further breaking. So let's do that real quick. I'm going to go back to my building demolition node. I'm going to find my constraints. And remember, we created a delete node that actually right now I'm not using, because in the end we deleted these constraints in the sub solver. So I will use it instead to break this corner of the column where the ball is impacting. So let's check where the ball will impact. And it's right here in this corner. So I'll select the delete node, press enter, and change the bounding box. Let's make it smaller. Let's try with 5 meters. And move it towards the column. We may need this from the side view. And I will also change this to bounding sphere. Let's try with 3 meters. And let's go with this for now. So I'll go back to my DOP network. And we need to add a little bit of Z direction here. Let's try with 40. And I'll also add a negative y direction, minus 10. And let's see how this works. So this is much more what I expected. Let's take a look through the camera. And this is starting to work very nice. So at this point, much of the work will be iterating and changing the parameters to suit your design. For example, in this case, I'm seeing a huge destruction. I'd rather have a more subtle explosion here. So I will decrease the radius of the cannonball. I'm also seeing that right off the bat, most of the connections are being broken. So maybe we will need to increase the strength of those connections. So for now, I will just decrease the radius of the cannonball and create a final flipbook to show you how to cast your final simulation. So let's real quick go back to the cannonball geometry. Change the size to, let's say, 0.5 meter. And resimulate. And I think this is much more what I had in mind. Again, you may have to do more testing with the strength, with the timing. But for now, let's move on so I can show you how you can cache this simulation.